Okay, so this is the Kruskal algorithm. So try to execute with same um, weights. Say this is a weighted graph. Weighted graph will have always a direction. So let me give as from A to A. This is 9. Whenever we observe a weighted graph, we don't have the path as the same from A to B. If we have one value, B to A may not be same. So um, from A to B, let me give it as 3. From B to C, I will give it as 8. From A to D, I will give it as 12. So from B to A, I will give it as 12. From B to B, I will give as triple nine. From B to C, let me give it as 1. And from D to B, I will give as 4. So from C to A, I will give as 3. From C to B, let me give as 4. And from C to C, I will give as E, and I will give it as 4. And from D to A, I will give as 1. And from D to B, I will give as 4. And D to C, I will get as 2. And triple nine for so to all the loops are being avoided in this particular program. Minimum spanning cross is just 4. So from starting from node 1, know how the nodes are connected from 1 and 2 and 2 and 3, how all the nodes are interconnected among them. It is the total cost. Mean it will just find out the minimum cost between the number of edges, how all the nodes are connected with each other. So 2 3 is connected with minimum value 3, 4 and 1 is connected with 1, 4 and 3 are connected with 2. So we just add all of these, we'll get minimum spanning tree. So moving on to the next, um, this is Prim's algorithm. So we'll complete with this Prim's. Um, the programs are taking a bit more time to load. Sometimes it do happens. Again, this is unweighted directed graph. So again, let me see. Okay, this time it took very little time to execute. So let me give the number 4 vertices. So let me give the directed graph. See, in Kruskal's, we just find out the minimum value in all the edges. Here, we will try to connect all the nodes from one source to all the nodes. Mean in the Kruskal's algorithm, we try to find the minimum edges between the between the nodes. So minimum number of edges we see with respect to vertices. Here we try to find out the path from one source, how they are connected to all the vertices with minimum edges. Also we try to avoid loops. Same way we try to execute this and observe how what kind of output we get. So again, this is in the same Prim's algorithm. Also we observe that from path from A to B is not same, will not have same weight from B to A. So let me take from A to B as 6, and B to C as 4, and C to D as something like 1. One more point I want to mention in the Dijkstra's algorithm or in the previous algorithm like Kruskal's, we don't see a path from uh, one node to the same node. Example, I cannot reach from source node to source node using either Prim's algorithm, sorry, not Prim's, or Kruskal's or Dijkstra's. But using Prim's algorithm, from all outgoing path, I will just find out if there is a path from A to A from any alternate path. So we'll observe that. I'll just tell you once I see the output now. So from B to A, I will take it as 7. From B to B, take it as 999. So from B to C, let me take as a 6. From D to B to D, I will take it as 1. So from C to A, I will give as 3. From C to B, I will take it as 7. From C to C, let me take as 999. From C to D, I will take it as 2. So continuing with D, so D to A will have value 5. From D to B, I will give it as say 4. From D to C, I will give it as 5. And from D to D, I will give it as 9. So in the source vertex, I will give it as 1. So now try to observe the output. So from 1 to 1, I can reach with the value of 4. So this is the source vertex. To reach 1, the value is 4. So using through 4, I can reach 1 back. So 1 I can reach 3 with the cost 4. So mean sorry, if I am if, first I will try to identify the minimum value from 1, which is the nearest value. Nearest value is 4, that is with the value 1. And the next is in the first iteration, we observe that which are the nodes which with minimum value. With minimum value, I have two nodes that from source which are the minimum value in the first iteration. So in the first iteration, I observe that from 1 to 4, I have only one direct edge with the fourth vertex, so the value is 1. Similarly, in the next iteration, what is the next value? From source, I can reach to node 3 with what cost? The cost is 4. So I can reach from 1 to 3 with the cost 4. Same way, I will reach from 1 to 2 with the cost as 4. Now we also observe that 1 is connected to 432. Mean all the nodes will be connected to the source node in a minimum way, maybe with respect to some intermediate node or direct path, but with minimum cost. We also observe that if there are any intermediate nodes occur with minimum cost, that will be considered. Saying this, see here in this case, I am trying to reach node 2 with the help of 4 with the minimum value as 4. I may not have direct connection to node 4. If I am going with direct, I may have some other value which is more greater. So I will drop out that and go with reach node 2 with the help of 4 with the cost value as 4. So on addition, if I try to find the overall addition of all the values, I will try to get my spanning cost is 9. So this 9 gives us the maximum value for the overall cost of this particular tree. So these are the some kind of algorithms. Um, 11th is minimum subset. Okay, I will continue.